Okay, welcome everyone. I'm hoping everyone's doing all right during our remote learning. We're going to continue where we left off in building polynomial functions and looking at the idea of factored form and zeros and multiplicity and all that. So let's get into it. I'm going to try to keep this video short, but it might be a little bit longer because we have a little bit more to go through. All right, so we have a little warm-up, so you can write these down. You can pause the video and try them yourself. I'm going to distribute this quick. This will distribute to 2x squared minus 10x equal to 0. And we want to know how many zeros can each quadratic function have. So this is a quadratic because it's second degree. And let's look at it in factored form here and use that zero product property to set each factor 2x equal to 0 and this whole thing x minus 5, and then solve. So this, you divide by 2, you'll get x equals 0. Here you add 5 to both sides, you get x equals 5. Notice there are two solutions, and the quadratic function, which is a polynomial with second degree, has that highest degree term, which is 2. So we're going to say that a quadratic function, I don't know why I had to write this again, quadratic equations have at most 2 zeros. How many zeros can a polynomial function have? Well, here we have a polynomial function, and if you use the box method, you're going to find that this will factor to x squared plus 4x plus 3, and then let's see, again, you can use the box method again here, but I'm going to not go through all the steps. So this would be 2x cubed, and let's see here, I'm going to have a negative x squared and an 8x squared. So that's going to give me 7x squared. And then, let's see, we have 6x and negative 4x. So that's going to be 2x and then minus 3. Notice this is a third degree polynomial, and if I set each one of these factors equal to 0, this one is going to give me, if you do it, 2x minus 1 equals 0. Bring 1 over, add it to both sides. This should give you x equals 1/2. This will be x equals minus 1, and this will be x equals minus 3. So we have 1, 2, 3 solutions. And that's the big idea, is that a polynomial function can have at most a polynomial function with nth degree. That means that the polynomial is n, or the degree is n. The polynomial function with nth degree can have at most n zeros. In other words, it can only have as many zeros as the highest exponent. So if it's a 5th degree polynomial, it could only have 5 zeros. It can have at most. And we'll see what I mean here by this at most in a second. At most n zeros. All right. Again, you can pause the video. This is the warm-up. So you can take notes in these or not. It's up to you. I would definitely do it when we get to the examples in a second here. Let's just zoom out just a little bit. All right, how many zeros do you think the polynomial function f of x equals x squared times x minus 1 cubed? So this is going to be, let's think here, how many factors are here? Well, this has really, it's x times x, right? And this is like x times x minus 1 multiplied by itself 3 times. So there's like 5 factors here. And I said that as a question. And we're going to see that, well, this is repeated twice, isn't it? And if I wrote this out, which I'll do, how many times is it repeated? 3 times. And that's going to be important. So there's only 2 unique zeros, but they are repeated. Okay, and that's going to be an important thing because it's going to tell us a lot about the graph, and we've touched on this a little bit. But so if a linear factor of a polynomial is repeated, then the 0 is repeated. A repeated 0 is called a multiplicity 0. Okay, perfect. A multiple 0 has a repeated, has a repetition. I can't spell. Repetition of the number of times the 0 occurs. This sentence maybe doesn't make sense, but basically the 0 is repeated, right? That's the main idea. All right, again, you can pause the video if you need to write this down. So now we're going to practice our factoring, and we're going to have to review how to factor quadratics a little bit here. But we're going to start by trying to factor out a GCF. Always try to factor out GCF. So here, what is our GCF? Well, the coefficients don't really have a GCF, but the variable, well, we can pull, let's see, this is 1 factor of x. So at most we can factor out 1 factor of x. We'd be left with x squared minus, divide this by x, so 4x plus 4. And that's equal to 0. And now you can factor remaining quadratic. And remember, we looked at, this is a quadratic in standard form. It has a b value and a c value. We want factors of c that add to b, which is negative 2 and 2. I'm going to start going a little faster with factoring and not write out all the factors every time. Now this can be rewritten because x minus 2 is repeated like this. X minus 2 squared. So what are my zeros? Well, x is 0 exactly when x is 0, and x is, this factor would be 0 when x is 2, and it's going to have a multiplicity of 2. This is going to be the convention in how we write it, how we designate a zero's multiplicity. We just write mult and then the multiplicity. All right, let's look at b. H of x is equal to x to the 4th plus 6x cubed plus 8x squared. So, and notice here, this has 2 unique zeros, but 1 is repeated, and it was a 3rd degree, which is what we should expect. So here we should expect 4 factors, maybe some repetition, we don't know. All right, this, let's see, GCF. Well, how many, the coefficients I can't do anything with, right? But I can factor 2 factors of x out of each one of these terms, because 2 is the highest degree that I see. So x squared, and then this would be x to the 4th divided by x squared is x squared. You subtract these exponents, remember, plus 6x subtract the exponents, plus 8 equals h of x, not f of x. And then we can factor this remaining quadratic, and 8 times 2, or 4 times 2 gives you 8, and 4 plus 2 is 6. So this is x plus 4, x plus 2, x squared is equal to h of x. Okay, x squared is equal to 0. Well, this is x times x, so really set x equal to 0, and it has a multiplicity 2. This would be x is equal to negative 4 to make that 0, and x is equal to negative 2. Now, one thing that I should add here, you don't have to write multiplicity 1. If you don't write anything, it's assumed that it's multiplicity 1. So you don't have to write it. All right, last one. F of x is equal to 4x squared minus 16x. So I can take a 4 out of both, and I can take an x out of both. And I'd be left with x minus 4. Set it equal to 0, and you'll get x equals 0 when 4x is equal to 0, right? And then divide by 4, you still get 0. And then this is x is equal to 4. So this is a quadratic, and it has, 2 zeros that don't repeat. This one was a 4th degree, and it had 3 zeros. One of them appeared twice. Right? Good. So now we're going to use this idea to write polynomial functions in factored form. So here, write a polynomial function with zeros at negative 2. So if it has a 0 at negative 2, it'll have a factor of x plus 2. And 3, so a factor of x minus 3. And this has a multiplicity of 2. And we're done. If I'd have asked to put it in standard form, you'd have had to multiply all this out, but I didn't. Write a polynomial function with zeros at 1/4 and negative 8. Okay, well, it doesn't tell me about multiplicity, so I'm just going to have them be multiplicity 1. X minus 1/4 would give me a 0 at positive 1/4. And x plus 8 would have a 0 at negative 8. Shout out to Javier. Okay, last two. These are going to be sort of challenge problems where you have to put them in standard form. So if you would like a challenge, you can do these problems. I'll just put it in factored form, and I'll let you put it in standard form as an exercise. So let's see here. This is going to be zeros at negative 4, so x plus 4. 1, x minus 1, and 0. So that would just be an x up front. That's going to be f of x. And we'll erase that. Okay. And now this is kind of an important idea, is that a factor, or a 0 at 0 will just have an x factor. So let's see here. Let's actually factor it out, because I did ask a couple other things and I want to review it. I'll leave this one as an exercise. If you factor out this quadratic, you're going to have x squared, and then let's see, plus 3x minus 4. And then when you factor this x through, right, it's just going to increase everything's degree. So this would become x cubed plus 3x squared minus 4x. So this would be end behavior. Let's see, it would be like this, right? It's a third degree polynomial, so it's going to be down, up, and it has a positive leading coefficient. And the y-intercept is actually, think about this, if you just add that linear term of 0, which doesn't affect it. So y-intercept is 0, 0, and this is the end behavior. All right, and I'll leave you guys to do D as a challenge problem, which you can do optionally for some extra points. Extra points.